No one expected China's Tianwen, one orbiter, to be the spacecraft that would get the clearest look yet at 3IATLAS, the interstellar object that has turned every space agency on Earth into a sleepless mess of calculations, emergency meetings, and quiet panic. But in a twist that stunned even Chinese mission planners, Tianwen-1's high-resolution cameras recorded the object drifting near Mars, brighter than expected, larger than anticipated, and behaving in a way that immediately sent analysts scrambling to understand what they were seeing. Before we move on, make sure to like the video and subscribe to the channel. It started as a routine calibration sequence. Stay with me through the last minute of this video, because the conclusion raises a question no single researcher can answer alone. When you see the final finding, drop your insight in the comments. I'm genuinely curious where you stand. Tianwen-1 performs periodic sky scans to maintain orientation, test optical systems, and track dust behavior around Mars. But this time, the onboard cameras flagged something unusual, an object not in the database, moving against the star field at a trajectory that didn't match any known asteroid or debris. The brightness curve caught the AI-assisted detection system first. Then Mission Control in Beijing noticed. Then, once the orbital ephemeris was matched, they realized exactly what they were looking at. 3IATLAS, the interstellar visitor, the cosmic enigma causing global scientific chaos. China immediately turned the spacecraft's medium and high-resolution cameras toward the object. What Tianwen-1 captured next was so unexpected. The Chinese National Space Administration, CNSA, classified the first internal report for nearly 12 hours before releasing heavily processed images to the public. But even the processed versions were jaw-dropping. The photos showed 3IATLAS not as a faint, distant, but as a clear, structured object with visible asymmetry, sharp ridges, and a turbulent tail that didn't match any known comet behavior. Instead of a smooth, dusty coma like a typical comet, 3IATLAS had what appeared to be layered material peeling away from its sun-facing side, almost like sheets of reflective plating or brittle crust fracturing in slow motion. Even more bizarre, Tianwen-1 detected faint luminous arcs around the object, as if extremely thin vapor plumes were curling off its surface and refracting sunlight in structured patterns. Not random, not chaotic, structured. The moment CNSA realized the significance, every instrument on Tianwen-1 capable of pointing toward deep space was reoriented. Spectrometers locked on. Thermal imagers measured emissions. Radar tried to ping the object, but returned mixed results, weak reflections, inconsistent with a purely rocky or icy body. NASA later admitted, very reluctantly, that Tianwen-1 captured details Hubble and Webb could not. Webb can produce unmatched spectroscopy, but at that distance and angle, it cannot match the spatial geometry of a Mars-orbiting probe staring almost sideways at the object's flank. One of the most striking images shows 3IATLAS passing through a thin patch of Martian dust atmosphere trailing upward from the planet's upper thermosphere. The dust refracted the sunlight reflecting off the object's surface, revealing subtle banding, almost like segmentation lines, running lengthwise along the body. They weren't erosion features. They were too straight, too parallel, too evenly spaced. Several scientists privately compared them to the panel seams of spacecraft hulls. Of course, publicly, no one says that. Not yet. Other images captured an even stranger phenomenon. A faint blue-white glow near one end of the object, pulsing softly, almost imperceptibly. Tianwen-1's photometric instruments logged the pulse at a cycle of roughly 38.5 seconds, uncannily close to the 41-second venting rhythm detected earlier when 3IATLAS spewed water like a ruptured pressure tank. If those two events are connected, it would mean 3IATLAS hasn't just passed through the solar system randomly. It has been active the entire time. CNSA's official explanation is cautious. Unusual sublimation, uneven heating, potential cryovolcanic activity. But the analysts behind the scenes know the patterns are too regular, too coherent, too consistent with a system, whether natural or artificial, that has internal structure. The timing of the images also matters. 3IATLAS passed near Mars at a distance far closer than any earlier projection suggested, implying once again that its trajectory has shifted. Not dramatically, just enough to cause alarm. Enough to suggest the object is responding to thermal or gravitational forces in a way that does not match standard comet physics. Some astronomers in Europe noticed something else. The object's apparent rotation appeared much more stable in the Tianwen-1 images than in earlier Earth-based observations. Rotation typically slows or becomes chaotic after fragmentation or uneven outgassing. But 3IATLAS looked like it had corrected itself. Its long axis pointed with surprising consistency. This could mean several things: internal mass redistribution, aerodynamic-like stabilization, or, as some whispered privately, active attitude control. The biggest surprise came from Tianwen-1's infrared observations. The thermal signature showed distinct hotspots, localized areas of heat radiating outward like vents. But they were too warm, too sharply outlined, and too symmetrically placed to be explained by solar heating alone. One hotspot appears near the object's narrow tip. Another sits along the midsection. A third near what looks like a fractured seam. Heat means activity. Activity means energy. And energy means something inside 3IATLAS is changing. The release of the images sent shockwaves through the global scientific community. NASA scrambled to redirect both JWST and multiple deep space tracking arrays toward the new coordinates. ESA issued a statement acknowledging that Tianwen-1's vantage point offered unique observational advantages. Japan's JAXA complimented CNSA's significant contribution to interstellar object research. But behind all the polite diplomatic language, the truth was obvious. China got the clearest look so far at the most mysterious object in the solar system. And those images raise far more questions than answers. For one, why is 3IATLAS becoming more structured the closer it moves toward the inner planets? Most comets become brighter and more chaotic. This one is becoming more defined, almost assembled. Second, what caused the faint electric blue pulsing? Tianwen-1's photometers detected spectral lines consistent with ionized oxygen, something extremely unusual for an object of this size and composition. Ionization means energy input. Something is pumping energy into certain materials on the object's surface. Third, several images show what looks like particulate spray following the object in a tight arc, not dispersing randomly like dust but clumping. Some experts suggest it's charged material interacting with the solar wind. Others think it might be ejecta from microfractures. But a few, quietly, say the arc resembles a plume shaped by magnetic confinement, like a faint electromagnetic tail. Finally, the geometry of the object itself looks more refined than any natural body its size. It doesn't have the lumpy randomness of comets. It has stacked layers, straight ridges, linear features. Even the reflective surfaces seem arranged in a way that suggests internal compartments. Could all of this be natural? Yes. Nature produces astonishingly complex objects, hexagonal storms on Saturn, perfectly spherical stars, crystalline asteroids. But 3IATLAS is an interstellar traveler, one that has now displayed fragmentation into perfect modules, synchronized pulses, water jet activity, trajectory anomalies, thermal hotspots, layered segmentation, electromagnetic interactions, now high-resolution structural features. At what point does coincidence end and pattern begin? Whatever 3IATLAS is, natural probe, ancient vessel, biological seed carrier, or just the strangest comet to ever enter the solar system, Tianwen-1's images bring us closer to the truth than we've ever been. And yet the mystery deepens. If the object is active, what is driving the activity? If it is stabilizing, why? If the pulsing is real, what is being triggered? And most of all, why did the interstellar visitor pass so close to Mars? Was it chance? Was it physics? Or was it something else? Now we face the questions everyone is asking. What exactly did Tianwen-1 capture near Mars? Why does 3IATLAS show features no known comet should have? Is the pulsing a natural venting cycle or something more deliberate? And what happens next as it moves deeper into the inner solar system? What are your thoughts? Let me know in the comments. And don't forget to like the video and subscribe to the channel.